Let's do another example here. We have our chiral center. Identify the atoms directly attached. We have an oxygen, hydrogen, nitrogen, and carbon. Once again, for reference, let's look at the periodic table. And based on the atomic numbers of these things, oxygen is our highest atomic numbered atom, atomic number 8. So that will be priority 1. All right. Next, we have nitrogen, which is atomic number 7, priority 2. Carbon, which is atomic number 6, that's priority 3. And hydrogen, atomic number 1, that's priority 4. Now we have to get our priority 4 group to the back, and there's a couple of ways you can do this. One way you could do this, if you're comfortable, is just to flip this molecule over horizontally, and that'll flip this OH to the right side, this ethyl group to the left side, and that horizontal flip will put the hydrogen back and the NH2 out. So that's one way to do it. Another way is similar to how we did the previous example, and that's what we're going to do in this case, because it seems to be a little more foolproof and a little bit less likely for people to make mistakes when they follow this route. But let's hold one group constant and rotate the other 3. So since the ethyl group's kind of our biggest group that I don't feel like moving, I'm going to hold that one in place. Then I'll rotate the other 3 groups around cyclically, which means I'm going to rotate the hydrogen to the back, the nitrogen into the plane, and the OH out. When we do that, we still have our ethyl group here. Then we have our wedge and our dash, but after that rotation, I have the OH up here, the NH2 in the plane, and the hydrogen back, which is where we want it. Okay, just relabeling this with our atomic numbers. We've manipulated the molecule so that priority 4 group is back. Now, all you need to do is draw your curved arrow from 1 to 2 to 3. This arrow is going around to the left or counterclockwise, so that means this chiral center has an S configuration. Right, but this is a good place that I can teach you a trick you can sometimes use. Right, but this trick works if and only if the priority 4 group is pointed out. So the priority 4 group has to be on a wedge for this to work. The trick is, don't move it back, okay? Just draw your arrow from 1 to 2 to 3, and then give the opposite assignment of what it appears. So if we look at our original molecule again, we have it with this hydrogen, priority 4, pointed out. So then, let's draw our arrow from 1 to 2 to 3. And this is going around to the right. It looks like R, but this hydrogen is out, or I should say the priority 4 group is out. So it's actually the opposite of R. It's actually the S configuration. So that makes it a lot simpler. Just make sure you're careful, because if the priority 4 group happens to be in the plane, you cannot use this trick. You'll have to just do a regular rotation to figure it out.